My name is Siddharth Satya, and I'm in the class for Intro to Data Science, and this is my final project titled Evaluating the Impact of Heuristic versus Learned Features in Students' Performance Prediction. So, as you can see my screen here, we'll start off with the abstract and why I kind of chose this topic. So, during my research, I found that older systems, academic systems used to use hard-coded Java to predict or compare student success. So what I wanted to do was take a Python approach to this problem and see how using PyTorch and other methods would compare to the Java way. So here were my ultimate findings. Ultimately, we found that the Java model was faster, significantly faster, while the Python model was significantly more accurate. So first, I did some research on comparing the two models. The Java heuristic model was hard coded and sometimes used Oracle-based platforms. The advantage to this system is that you can completely explain what your code is doing, and tracebacks are easier. Another advantage is that the delay in the Java systems is less. This compared to the machine learning models, which use various different types of analysis to predict student outcomes. For example, the multi-layer perceptrons, they build a standard network and they can predict student outcomes while taking into account multiple features. Some of the features I specifically use were study hours and things like that. And then I also use regularization to make sure that the model wasn't overfitting to the trained data, so that new data could also be analyzed equally well. Uh, the next part of this was kind of confusing for me because it was the black box problem. So the weight analysis used in this case, uh, certain features would have a lot greater effect on the pass fail prediction. Um, and then for my method, so first I started with setting up the problem, obviously, and denoting ones as passes and zeros as failures. And then I created a matrix to represent all the features and their weights, which we can see. Uh, where is it? I think I had it. Here. We can see how they affected the final results of the data. And then then we'll move on to the core findings. So, like I said before, uh, the Java model was much faster, while the machine learning model was slower. In fact, 8.4 times as slower. So I felt that this was a really good finding for my research and work because I actually wanted to see exactly how much of a difference would make depending on what kind of architecture you used. And here I have a heat map uh, that shows how accurate predictions were in my work. Uh, I also previously mentioned the weights for each of the features, and I found that the weights were pretty accurate in regards to like attendance rates, the amount of tuition paid, and study hours. Then here was the chart I made to ultimately compare the Java model and the PyTorch model. As we can see, uh, the PyTorch is more accurate, while the Java model is faster. And in addition, the Java model does not include regularization and is more explainable. So in terms of interpreting, I mean, we discussed the architectural trade-offs. Um, Limitations and future work. This is where I kind of explored what further work or research I could do in this field. The first one was obviously feature sparsity because there can be a lot more factors into what makes a student pass or fail. Uh, in addition, geographic specificity. obviously, different regions have different kind of factors influencing students passing or failing. Um, oh, some of the constraints I had were was firstly the model depth. I think you can add in layers to further increase the accuracy of this model. And then for my conclusion, I briefly mentioned it before. The Java model was much faster compared to previous used Java models, and the machine learning model was slower but more accurate. And then here are my references that I use for the project.